let me know. We'll just see a quick example of conversion of ambiguous to unambiguous, and we'll finish. This is very simple. In case we have understood all rules till now, we'll be able to easily do it. So E plus E, E asterisk E. I'll teach one string alone. The next string, like, we'll see it in the next class. So just, we'll see it for one string alone. For the next string, we'll see it in the next class, okay? Just the meaning of ID plus ID plus ID. Now, why do I use ID here is ID means identifier, okay? A variable. Any variable could go at that place. We are just bothered about plus and asterisk. Okay, so those are terminals. ID is any other terminal, can be replaced with any variable. Okay, so that is why we use ID over here. That's an identifier. Okay, now first check. Let us check if it's ambiguous or not. I think we have already done this with plus and minus. Yes, given this generic set of production rules, obviously I can either choose plus first or asterisk first. So I'm not going to choose asterisk here because it's only plus. I can apply it from left or from right, and I will get two parse trees. I will choose to start with E plus E. I have to because it has only plus. Okay. Now my option, I can either leftmost derivation or rightmost derivation. Which one should I use? I can choose. I prefer leftmost derivation, E plus E. Just replace everything with ID. Okay. So this is leftmost derivation. I keep replacing from the left symbol. So this is leftmost derivation. So let me do a rightmost derivation for the same problem. E. I don't have to choose an asterisk rule because that's not in my symbol. String. So I choose to expand the rightmost non-terminal. So I've chosen to expand the rightmost non-terminal with again a plus. Now we'll substitute with terminals ID. So as we can see, both generate. So this will start from this. Okay. So it goes like this. This will start from this. So it goes like this. Then sees this plus and comes over here. Okay. So this will generate. Now first ambiguity, two different parse trees for the same string. So this generates something like this. Okay, so this plus is executed first or associated first. And here the rightmost plus is associated first. Now we saw in the example, this is wrong according to associativity rule and this is correct. So there is some sort of ambiguity to the compiler and there is some incorrectness also. Now, why does this occur? This is because I allow too many choices. Okay, what are the choices that I allowed in my grammar? So in my grammar, what did I allow? I allowed you to expand both in the left and right directions. Am I right? I did not restrict you anyhow. You can expand in the left, you can expand in the right also. Okay. But which one is valid for this case? Only the leftmost derivation is valid for this case. Rightmost derivation is incorrect. Okay. Then my grammar shouldn't have allowed you to expand the right side at all. Are you understanding? So my grammar shouldn't have allowed you to expand at the right side at all. So what do? I will restrict so that right expansion is not possible. That is what you should do. Restrict your production rules such that right derivation is not possible. Okay. Right expansion is not possible. You have to do this restriction. Now I'm going to change this E rule. First production rule. E tends to E plus E. This created the problem because I'm not worried about the second rule. We'll see that in the second example. Now only this production rule I'm worried about. I had options of expanding the right also. So that is why I had problems. I choose to expand right first. So that you allow, the grammar allows, then what is the issue? So I should not do this. I should restrict this. So I'll replace this production rule with E plus ID. Okay, just replace this production rule with E plus ID. For now, let us forget about this production rule. We'll consider the other production rule. this also. Now let us try to create the parse tree for the same expression. So I'll start with symbol E, start symbol, okay? E can be replaced with what? E plus ID. Now this is a terminal. I've not even given you the choice wherein you can use the, or you can expand or grow the right side of the tree. So the right side of the tree cannot grow at all. So that is restricted. So I have to again expand this. So I want 2 plus in my final string. So I want 2 plus in my final string. So what should I do? I can't directly substitute an ID. I again go for E plus ID. Again, I can't expand this any further. Okay, so just replace this with ID. Now the bottommost is at the left, am I right? So we get the associativity correctly. ID plus ID, left is associated first, and then this ID will be executed. So we have a left associativity. Now, as you can see, when I've restricted my grammar, okay, when I've restricted my grammar, I have reduced the choices. Thereby, I have eliminated the ambiguity. Okay. Yes. So this is called as, so I allow my tree only to grow in the left direction. Okay. So when you allow the tree only to grow in the left direction, parse tree grows in the left direction. Okay, only this is allowed. Then it's called as left recursive grammar. You will study this extensively in compiler design, I believe. I think we'll also touch upon this. Left recursive grammar. Okay, so it grows in, when you're restricted your parse tree to grow only in the left direction, it is called as, the grammar is called as, the grammar only restricts, right? You have changed the grammar so that I restrict the tree to grow only in the left direction. So where the grammar is called as left recursive grammar. Okay, fine. So next class we'll see an example with precedence. Now here precedence was not a problem, only associativity problem we have dealt. So next class we'll